Welcome. Yeah, so I have a really fun question on local extrema here for you. It's actually a fun, challenging example. I didn't have the space to fit in the challenging part, but anyway, it's fun. All right. As always, to start, thank you, Lord Christ, for everything. You're amazing. The devil is like really strong because he has so many allies, as I've said before, but with Jesus, we're stronger, right? Okay, cool. All right, so let's get started. So what's interesting and different about this question as opposed to any other question that you're asked about local extrema is the fact that our function g is given as an integral. So g is defined as an integral. Now, of course, by local extrema, we mean local minimums and local maximums. Okay. Now, anytime we're trying to find local minimums and local maximums, what we have to do is take the derivative of whatever function we're given and set it equal to 0. Again, what's interesting here is our function is defined as an integral. So we have to take the derivative of this integral. But wait, when have we seen taking the derivative of an integral before? I know, the fundamental theorem of calculus. As a matter of fact, the real fundamental theorem of calculus, because some books present the fundamental theorem of calculus in two parts, part 1 and part 2. One of them is actually called the evaluation theorem. There's really only one fundamental theorem of calculus, and this is what it says. It says that if you want to take the derivative of the integral from some constant, say a, so the constant a here is 0, but it didn't matter what the constant was, but from some constant to x of some function f of t dt, then this is going to equal f of x. It's a really neat result, and I have a number of really fun videos on it, including proving this in 4 different ways, so check out those videos. But yeah, this is what it says. Okay, cool. So then after all, it's very easy to find the derivative of g here, because g prime of x is going to equal, by the fundamental theorem of calculus, we have to take the derivative of this, and so f of t here is represented by cosine of t squared plus 2, so we see g prime of x is going to be simply cosine of x squared plus 2. But if you heard me right, I said that after we find the derivative, when we're looking for a local extrema, what we do is set the derivative to equal 0, right? So we do that. So we set this equal to 0. Okay, cool. So we're trying to figure out where cosine of x squared plus 2 is equal to 0. Now, let's substitute that x squared plus 2 is equal to theta. Also pay attention, we're given an interval in which to look for our x's, our desirable x. But with this substitution, now what we're trying to do is figure out where cosine of theta is equal to 0, right? Okay, that isn't very hard. We remember our cosine graph really well. So like if this here is like 2 pi, right? This here is 2 pi. Then between 0 and 2 pi exactly in the middle is pi, obviously, and between 0 and pi is pi over 2. And then between pi and 2 pi is 3 pi over 2. So we've got pi over 2. That 2 is poor. Okay, we've got pi over 2, 2 pi over 2, or pi, 3 pi over 2, 4 pi over 2, or 2 pi. So next is 5 pi over 2. This is all we're going to need as far as the graph of cosine to the end of what we're trying to do here. Okay, cool. So if this is -1 and this is +1, right, we could do this, which is we know cosine starts at 0, 1, otherwise comes down to here, and then bottoms out here, and then comes up here, peaks again at 2 pi, and then comes back down, right? Okay, cool. So from my visual, the places where cosine of theta will equal 0 are for theta equals this spot, that's pi over 2. Remember, we're after x, not theta, but this substitution will help. This spot, which is 3 pi over 2, right? And then 5 pi over 2. Okay, which is right here. There are infinitely many more places along the x-axis where cosine of theta equals 0, but for the interval concerned here for x, these are all that we're going to need. In fact, you'll see that we don't need pi over 2, because what happens is, well, now that we figured out theta has to equal one of these 3 values and more, but just those 3 values for our purpose, what we're going to say is x squared plus 2, which is theta, is equal to first pi over 2, and let's look at this. So other than, this question being tricky by virtue of the function g being defined as an integral, the other part that's tricky in this question is you have to have really good number sense, but I'll teach you, so don't worry. Okay, so First, if we attempt to solve for x from where we're at right now, we're going to write x squared is equal to pi over 2 minus 2. Now, for pi, let's use the approximation that pi is approximately equal to 3. Yes, it's 3.14, but 3 will suffice for the purpose that we want it here. Okay, so if pi is approximately 3, then even if we use 3.14, half of it minus 2 is a negative number. And next, to get to x, we'd have to take the square root. But we'll end up doing the square root of a negative number. That's no good. So this here is no good to us. All right, so we move on to 3 pi over 2. So then now we're saying x squared plus 2, which is theta, is equal to 3 pi over 2. Okay, fine. This should work. So next we go x squared is equal to 3 pi over 2 minus 2. But 2 with a denominator of 2 is 4 over 2. Right? And so what that means is that we could just write one denominator. So we've got this now. Okay, so even if we use the conservative estimate of pi being 3, right? We know that we've got 3 times 3. So that's 9 minus 4. That's a positive number. So we can take the square root of it. So from here we see that x has to be plus or minus the square root of 3 pi minus 4 over 2. Now, as I said, this is about 9. 9 minus 4 is 5 over 2. But we have x going from 0 to about 3.14. So then we discard the negative square root because, well, that will fall on this side and we don't need that. Got it. Okay, cool. So this is one of our critical numbers, right? Okay, cool. And similarly, we go x squared plus 2 is equal to, this time, 5 pi over 2. 5 pi over 2. Got it. So from that, it means that x squared is equal to 5 pi minus 4 all over 2. This 2 is good because this is about 15, 5 pi, right? Minus 4 would put us at about 11 over 2. Yeah, we make sense of that. Okay, when is the next time cosine will be equal to 0? That will be what? 5 pi over 2, and then we skip 1, which is 6 pi over 2, right? And so that's 3 pi. 7 pi over 2. So if we use 7 pi over 2, we have x squared, x squared is equal to 7 pi over 2 minus 2, so that's 7 pi minus 4 all over 2, right? 7 pi is about what? 21. 21 minus 4 is going to be what? 17. The square root of 17. Well, no, we do 17 divided by 2. What's that? That's about 8 and change. And the square root of that is that going to fall in this interval? Yes. So actually we needed the 7 pi over 2, a continuation of this, right? Okay. All right. So the whole point is to teach you the number sense and kind of how to go about this. So it's not a big deal that, we don't catch all the critical numbers, but I think we've just now caught them. Okay, so 5 pi minus 4 all over 2 here, right? And we just added to the list also x equals, and for the same reason we don't write the minus square root, x equals 7 pi minus 4 all over 2 under the square root, right? Okay, got it. All right, so we got to put these numbers on a number line unless we want to use a second derivative test, and we're going to use the number line. Okay, sorry. Back. All right, so if we use the pattern that we have recognized, we know that another x that we could have written is x equals the square root of 9 pi minus 4 all over 2. Now, notice that 9 pi, using the conservative estimate of pi being 3, 9 pi is going to be 9 times 3, which is 27. It's actually more than that because you're using 3 for pi. So we've got 27 minus 4. What's 27 minus 4? Like 23, right? And 23, if you cut it in half, is more than 9. The square root of 9 is 3. So we see that this is going to put us outside of the interval that we're looking. So actually, the only ones that we need are this guy, and this guy. And as I said, you could either do the number line test, or you can do the second derivative test. For this problem, let's do the number line test. Okay, all right, so for that, let me get a number line. So we have this, and on this number line, we put our 3 numbers, right? And so our 3 numbers are this, but let's get a sense of where it's at. We already said the numerator is 5. 5 over 2 is 2.5. The square root of 2.5 is what? If we go by the fact that 2.25 has square root 1.5, it's about 1.5. We just need to know about where it is. We don't need to know exactly where it is. So if this is 1 and this is 2, then this here, the square root of 3 pi minus 4 over 2 is somewhere over here, right? Actually a little to the left, but again, all we care is that we know what 2 integers are around it. So this is, let's call it A. This is A, right? This is A, got it. And then this guy B is like what? We said the numerator is about 11. 11 divided by 2 is 5. 5.78 has square root 2.4, right? I'm going by the fact that like 5.76. 576 has square root 24, so 5.76 should have square root 2.4, right? So that's what I'm going off of. And we're doing estimations, legit estimations, but estimations nonetheless. So I just said about 2.4. So again, all we care is what 2 integers surround it. And so if this is 3, then this guy, if we call him B, he is right here, right? Okay, somewhere here. Okay, B, got it. And it looks like we need to extend our number line. I'll do that, no biggie, no biggie. So I knew I was missing something, and it's like the cap for my black pen. It's okay, I have another one. okay, all right, so what about this one? This one is 21 minus 4 in this part, right, about, and that divided by 2. 21 minus 4, we said about 17. 17 divided by 2, 8 and change. 8 and change, the square root is like, what is it going to be? The square root of 8 and change is going to be somewhere between 2 and 3, right? So did I forget to square root this number? No, 2.4. So, what did we do, guys? So did I forget to square root this number? That's 11 over 2, which is 5.5. The square root of 5.5 is, we said it's about 2 and change. So that's good for B. Maybe it's a little to the left, but how did this work out? So 7 pi is 21 minus 4, as we said, 17. 17 divided by 2 is not quite 18 divided by 2, so that's about square root of 9, but to the left of the square root of 9, so it's to the left of 3. Okay, this is a crowded field. Yeah, so to the left of 3. So if this number is called C, then C would be here. Now, because it's very crowded, I'm not going to write what C is. I'm just going to do it for these two and decide if these guys are local mins and maxes. And this number line is for G prime. In other words, like this field right there is too crowded. So, you know, you get the point. As long as you get the point, like, the labor isn't required, I guess. Okay, so we're plugging in G prime. So for to the left of A, we can plug in 1. So we decide, what is G prime of 1? Well, G prime of 1 is going to be equal to cosine of 1 squared plus 2. So it's going to be cosine of 3. I wish I didn't erase that cosine graph just about right now. Okay, so what's cosine of 3? Because again, we have to, lots of number sense in this video, we have to like figure out whereabouts cosine of 3 is going to be. I just drew sine. So cosine is this one, right? We already had it. Okay, so pi is right here. Pi is 3.14, we know. So 3 would be a little to the left of it, and we have to be talking radians, right? So cosine of 3, all we know is a negative number. That's all we care. So this is negative right there. Okay, and then G prime of 2 is going to be cosine of 2 squared plus 2, so 2 squared is 4, plus 2 is 6, so this time we're looking at cosine of 6. Okay, now we know 2 pi is right here, and we know 2 pi is a little more than 6, so cosine of 6 is going to be like projecting this over here, and so that is going to be a positive value. So we know that to the left of a, we're negative, and to the right of a, we're positive, meaning since we're talking about g prime, we're talking about the slope of g, meaning g is first decreasing, then increasing. Okay, so that means that a, this number, is a local min. Local min. Okay, so actually I'm going to abandon this video here because you get the point. Yeah? Alright, cool. I hope you enjoyed it. Keep watching. Take care.